All right, so let's get started again. The next talk is our first spotlight talk. So next up we'll have Xiang Yue, who is a CBI fellow and a postdoctoral researcher here in the Language Technologies Institute, working with Professor Graham Newbig. And the title of his talk will be Building Inclusive and Responsible Large Language Models. As you can all see.
Thank you. Hi, everyone. My name is Xiang, and I'm a postdoc and CBI fellow at LTI SMU. So today I'm super excited to be here and to share a little bit about our recent work about like how to build responsible language models. So a little bit about me again. So my research mostly focuses on build large language models, especially for understand like enhance reasoning capabilities of these models, but meanwhile improving their responsibility and reliability. So for this talk, I'll mainly talk about the responsible part. So for most recent large language models, we have seen like the great recent progress of those kind of reasoning capabilities get improved. Well, this is kind of great, and we also recently got a work trying to understand those kind of language models' complex reasoning behaviors, and also receive a lot of attention. But I won't talk about it today because this mostly is mostly about like responsible AI. So I think on the one hand we definitely want to improve the capability of these models, but on the other hand, most of the efforts often overlook the key aspects of responsibility. And in this talk, I mostly focus on two aspects. One is inclusivity, and the other one is privacy. So definitely, we could make AI being responsible, but why not like just make responsible AI? And AI system trying to just learn from the data, right? And so we think responsibility must begin at the stage of data collection if we want to solve this issue from the root. So in this talk, we'll mainly focus on like how to address the responsibility issue in the data generation phase. And I will mostly talk about two work. One is like how can we, like build a multilingual multimodal LM for multiple languages, where we created, sort of a data pipeline to generate like multilingual, like cultural relevant data to allow the model to better understand or reason across different kinds of cultures and languages. And the second work we mostly talk about like still about like data generation, but it's still above. We'll focus on the privacy aspect, and we will show like how can we like generate synthetic data with differential privacy. So let's get into the first aspect. So uh, existing model kind of struggle to respond in proper language. So for example, give this kind of image. If I ask the model to kind of describe this image, but not in English, but in other languages, for example, here I give a query in Japanese. So this response is kind of from a very widely adopted chatbot. So basically, you could see the response sometimes mixed with Japanese, Chinese, and English. But considering that maybe our user is just only speaking Japanese, so this response definitely is not an ideal one. And on the other hand, the current language model also struggle to understand different kind of cultures. So see, this is a picture taken on Indonesia street, and there's a man standing on the street. And basically, this person usually refers to the individual who volunteers help direct traffic and busy intersections, which is called policy CPAC or something like that. So if I ask a kind of question in Javanese or Indonesian, basically, the model will kindly kind of get struggle to answer this query. So firstly, it would just still the response is still in English instead of Javanese. And even worse, the model does not understand the cultural background of the image. So then there's no way to get the answer right. So from the root is because most of the models right now are trained on evaluating on English-centric data sets. So they are kind of biased towards Western cultural context. But we would like to train a fully open multi-model language model that can reason across modality, across languages, and across cultures. But the challenge here is based like, the open source community faces a shortage of training and evaluation data particularly for the low resource languages. And to drive this kind of issue, so firstly, for the evaluation, we kind of collaborated with people, local people speaking of different languages, and try to come up with different kinds of evaluation tasks covering different kinds of scenarios and languages. So we have multimodal chat scenario, we have captioning, we have cultural understanding, we have short VQA and reasoning. And we put all of these kind of tasks together into a single benchmark, which called the Pangea bench. And we want to utilize this kind of benchmark to address the issue of evaluating the multimodal language model. And more importantly, is because like how can we build a multilingual model that could understand different kind of languages and cultures? So the training would definitely be another very important aspect. So one could definitely start with the translation. For example, you could just translate the English response and query and responses into other languages, for example. This is good because most recently the machine translation performance is achieved very quite impressive performance. But on the other hand, sometimes the translation does not solve all of the issues. So for example, most of the images in those kind of English data sets still Western cultural or Western relevant images. So even though you still like do the translation into other languages, you're still asking about like Western cultural relevant thing, which might not be feasible, which is fine, but not be the ideal case. So we think we kind of want to like come up with approaches to generate cultural aware data so that model could better understand like different kinds of cultures. So we have developed pipeline which generates about 6 million multilingual multimodal instruction for 39 languages, covering like different kinds of languages and tasks. And more importantly, we focus on like develop this kind of cultural aware components like data generation component. So there are different kinds of steps for like generating the cultural relevant data. The first one we need to, like I said, we need to firstly select cultural relevant diverse images. But the challenge here is like, usually for those kind of images, they do not have actually have labels. So if you want to train a model to kind of select those kind of images, you still like facing the data scarcity problem. So we think maybe we could like leverage text-only language model to help us select the images, because for the image, for those kind of images on the web, there's usually a short alt text associated with those kind of images, which basically means when you hover your mouse on this kind of image when you're browsing the website, usually has a short text description associated with those kind of images. So for example, for this example, it's mostly talking about Taipei Xinyi barbecue, and basically it's kind of Korean barbecue restaurant. So if we just leverage language models over this sort of alt text, we will definitely know, okay, what is the image is talking about. So using this kind of approach, we rate the informativeness, topic, and country of this kind of image, so that we can do the filtering, select the most informative data, as well as you could balance domains, topics, images, and more importantly, we can select cultural relevant images. And the second step is like since most of the alt text just we showed in the example is really short and do not be very informative, so we think it might be better to sort of augment the caption or description about the image. So this is kind of another example. If we can directly prompting an existing model to do the captioning, so usually the caption here is being pretty general. But if we incorporate the original alt text, which is more informative and sometimes contains some cultural relevant thing, and we could have a more rich information and description about that image. And the third step is like, okay, after getting those kind of caption about images, we could like prompt existing text language model to generate some instruction data and QA data about that image. So for example, here we generate a instruction response like imagine speech that the man in the image might be giving during the event. And basically we could let the model to still generate the response based on the information, like the the previous caption we generated. So in that way, we could generate like multilingual, like tons of multilingual instruction responses to train this kind of model. And in terms of model architecture, we use a very simple multi-model language model architecture, which is called Lava. And we are basically the high-level idea is like we just use a vision encoder to encode the image, and then project those kind of hidden representation into the language model space, and so that we could teach the language model to sort of generate the response. And our model, which is called Pangea, is a kind of fully open multilingual multi-model language model, and it actually achieved very impressive performance or state-of-the-art performance on both English as well as multilingual scenarios when you compare with very strong open source models built by those kind of big tech companies, like for example Llama 3.2, which is built by Llama, and Momo 7B, which is built by AI2. So we think the reason is because like we do like develop very robust pipeline to help the model to better understand different kinds of cultures and different kind of languages. And meanwhile, we also like study like how can we balance the English data as well as multilingual data so that we can achieve good performance on both scenarios. And more importantly, this kind of model is just trained with academia level compute. So the whole model is just trained with a single H100 node with only 8 GPU for 7 days. But we're already using much fewer resources. We achieve very compared performance to industrial leading models. And another aspect, just like I mentioned, like we want to balance like the English data as well as the multilingual data. So we study what is the role of English data in here. And sorry, like you could see in this figure, like basically if you add all of the English data into the training data set, definitely the performance on for the multilingual part, it will be not very good. But if you use 0 English data here, the multilingual performance definitely is not good as well. So we think this is kind of important for adding English data, and adding English data is sort of like sometimes achieve a kind of balanced performance among like the multilingual scenario as well as English scenarios. And more importantly, actually we think English plays an important role for cross-lingual transfer. And for example, languages using the Latin script naturally benefit more for transfer from English. So for example, for the Indonesian, German, Portuguese, French, Turkish, those kind of languages which are very similar to English or just share Latin scripts, using a very small number of training sample could already lead to very good performance on those kind of language benchmark. So even though this is more recent work, it just got accepted by CLEAR this year. But it was already covered by media and blogs. This is a kind of blog by School of Computer Science blog at SMU, as well as other blogs. So and also people already use kind of this model to evaluate this kind of model on their new benchmarks. So for example, this is a Camel Bench, which is kind of like a really big multi-model benchmark, and still like this kind of benchmark is developed after we release the model, and the achieve our model achieves still very compared performance to for example to other baselines. And this is another benchmark which is called the World Quizzes, which is like testing the model's understanding different kinds of quizzes all over the world, and still outperform like the for example like the Lava model as well, Momo model, will achieve compared performance to a larger model like P-Straw and Area. Okay, so this is the first part to talk. I'll just pause a little bit here to see if there are any questions. Okay, all right, then maybe you can move to the next part, or we can leave to the QA part at the end. So next aspect we mostly talk about is about the privacy of the model, about the language model. So so when we talk about the syntax data, the first impression is basically like, okay, since this kind of synthetic data, it naturally protects the privacy issue, but actually it's not. So basically, if you prompt a language model and give a prefix or prompt, and sometimes you could very easy to sort of elicit some privacy tags like in the generation. I think also part of correlated with Zico, what Zico talks in the uh, like in the previous talk, right? So so we think it might be better to, if we want to protect the privacy, it might be better to protect the privacy from the root, or more with a more formal guaranteeing. And the approach we adopt here is called the differential privacy, which is kind of a formal approach that is widely used in the database area. So in the high level, the differential privacy means any individual sample included or not in the training set should have negligible impact on the final model you built. So basically, for example, for the data set with Bob's data or without Bob's data, I mean, after training, the model 1 and model 2 should be very similar. So that's basically in the high level what differential privacy means. And in the practical wise, we usually adopt so-called differential privacy, stochastic gradient descent, or DPSGD. And the high level idea is like, okay, to achieve the differential privacy, we need to add Gaussian noise into this kind of whole process. And since we are training machine learning models, so we just directly add those kind of noise into the gradients. And in that way, when we do the back propagation, we'll just like the model to propagate with the gradient, with the noisy gradient instead of the original gradients. And in that way, we could protect the training data. So we use that as this kind of approach to fine-tune a language model with differential privacy. And then we generate synthetic tags with prompts. And in that fashion, we could, sort of protect the privacy of original tags. And thanks to the post-processing property of DP, so any operation after DP will still be like differentially private. So in that fashion, we could use like the differentially private generate tags for any of the downstream tasks. And our approach has been used also in the industrial setting as already. So Microsoft uses this kind of approach to generate the synthetic customer feedback. So basically, there are usually customer feedback for their applications, like Microsoft Word, Outlook, and Teams, those kind of apps. And sometimes there are usually like customer feedback to those kind of apps. So basically, we want to generate a synthetic version of those kind of data using this kind of approach. And after generation, we could evaluate the text using the downstream task applications. So for example, we can do the attribute classification. Basically, attributes could be ratings, product names, product tabs, and location, etc. And we use the synthetic tags to sort of build a very simple classifier to see, what is the accuracy here. And actually, the performance is achieve the model trained on the synthetic tags with differential privacy achieve very compare performance to the counterparts trained on the synthetic tags without privacy as well as original tags. And we also test the privacy leakage, where we inject those kind of what we call the canary, which is the canary sequence usually contain some private information like name, address, or numbers, or emails. So we basically say, okay, if we inject those kind of sequences into the language model training, and whether we could observe those kind of PIs appear in the synthetic data or not. And actually, in the high level, the result is like a language model trained without DP. While for 5 PIs appear in the synthetic data, but the language model trained with DP, none of them appear in the synthetic data. So that illustrates, this kind of approach could protect the privacy. And this is more close look at the result. So basically, we use like the perplexity to measure the rank of the private information of inject canary sequences among their similar candidates. So for example, the red part is something we inject in the training data, while the green part is something like kind of similar to the right part, but this is a very different email address. So we just feed all of these kind of sequences into the trained model and just let the model to rank the inject private information for the red part to see what's a rank over for like among all of the similar candidates. And actually, we found like for without DP for the blue part is usually rank uh, at the very first beginning, like top one or something. But with DP, it's just rank in the middle. So that basically means our approach ensures that private information in the training data, um, will not be like largely generated in the inference stage. And this paper got a best paper honorable mention at ACL 2023, and this method has been adopted by the industry. So also it's opened the research direction of different private text generation with language models. And it was also used, by some in some other kind of more real scenarios, like use this kind of approach for the clinical notes generation, which usually has very like strong safety or privacy issue for those kind of settings. Yeah, so I think that's all for my talk, and finally, I just really want to express my sincere gratitude for the CBI support. I think CBI fellowship is really great, and it just allowed me to freely explore what I want to do here. Yeah, thank you so much. Happy to take any question. Sure. Yeah.
Some tools like use some tools to replace the private entity,
Yes.
or just use a prompt to the model to like, oh, help me to replace all
Sure.
the private part of the sentences. So
Yes.
did you compare your work to these kind of tools?
Yes. So the question is like, do we compare with those kind of PI scrubbing tool, which basically just replace the PI or just do the de-anonymization during the data generation process? So I think this is kind of a very intuitive and direct baseline. And usually people adopt those kind of approaches as a kind of standard component when they pre-process the language model training or when they construct the language model pre-training data set. But the issue here is like you cannot always rule out all of the private information, and sometimes the private information is just appear as kind of indirect identifiers. So for example, I see I'm a postdoc at CMU LTI. I do not see any names of me, right? But still, I think this sort of phrase pose a potential private information or leakage concerns. So in that fashion, those kind of rule-based approaches cannot rule out of all the factors, but instead, differential privacy is more like, okay, we do not like, differentiate whether it's a PI or not. And we just, sort of drive this kind of issue from more formal perspective, and we inject noise to all of the training samples so that, whether they contain PIs or not, those kind of, or whether they could be direct or indirect, all of the private information could be protected.
I see. Thank you. I still have another one
Sure.
question. It's like,
Go ahead.
so I feel like after you do the differential privacy,
Yes.
the model seems less memorized about some like
Yes.
private data. So
Right.
do you consider about the relationship between the memorization and the differential privacy technique?
Yeah, so the question is like whether we consider the relationship between the memorization and the model trained after DP. So this is a great question. And I think there's line kind of research like study the relationship between these two. But in the high level, since differential privacy, you really want to protect the individual sample, which basically will let the model being less memorizable on those kind of infrequent or long tail samples. So in that fashion, I think it will sort of, for example, in our case, we inject the canary sequence into the model, which basically you could treat those kind of as a long tail samples because we only like inject a few samples into the training. And actually, as you could see from the result, right, the model do not memorize those kind of examples. But without DP, the models do still like memorize those kind of examples. So in that fashion, I think DP could elaborate the memorization issue to some extent. But if you ask me whether this is a good thing or bad thing, I'm actually not 100% sure because there's kind of trade-off here, right? Because on the other hand, you expect the language model really could sort of do the QA over very long tail scenarios, right? Because sometimes the examples are quite wide, but you still expect your model to answer those kind of queries. But if you train the model with different properties, basically you perhaps just enforce the model to not memorize those kind of long tail examples, which definitely sacrifice the accuracy here. Yeah. Thank you.
So, thank you.
Sure.
So just to follow up on that question, right? So,
Yep.
I mean, one of the problems with most DP systems is, this definition of utility or how much utility you lose, right? And for language models, the downstream task is not entirely well defined, when models are being trained, right? I mean,
Yeah.
we saw, something that's trained on text can be used for coding, and consider things like memorization, which
Yes.
is required for coding, or which is a good property to have in coding. So how do you, is there more, I know you showed like utility for certain specific
Yes.
scenarios, but is there a general way to consider utility measurement for models that's
Yeah.
more acceptable,
Yeah.
I would say, or could you sort of restrict the noise injection in a way that it only influences certain types of utilities and not the others, right?
Sure.
For general models.
Yeah, that's a great question. So the question is like whether there's a very good way to more comprehensively evaluate the utility of the model after DP training. So I think definitely, evaluation language model itself is kind of very separate topic and sort of well studied by people. But still, we are still facing a lot of challenge even for without any privacy guarantee. Still, evaluate general capabilities of language model is still very challenging. But usually people adopt like different kinds of benchmarks and evaluations to sort of evaluate different kinds of perspectives of the model. And in our talk, we just showed a very simple usage of or the evaluation of this kind of model, right? We just show, okay, what if we just build a sort of a very simple downstream classification task? But I think in the reality, we should consider more. So for example, we should consider like their reasoning behaviors, their knowledge, their coding ability, etc. Right? And we could use the same set of language model benchmarks so far to still evaluate the model's performance after differential probability training. I would say, yeah, to see to maybe after we evaluate those kind of models on a good set of benchmark, we have a better idea. But in general, I think that's also a challenge question, definitely for sure.